Welcome back. And if you are at this point and you're looking at your Desmos.com and going, I don't know how to put a log in, that's perfectly fine. If you're here just to check, that's also perfectly fine. So sometimes putting a log into Desmos is a little strange because we actually have to add a base, and not all logs have bases. And that is something we'll get into the future. But for now, I want you just to know how to put it in with a different base, and our base being 4. So we're going to put f of x in here, just like our function has, and then we're going to go ahead and put equals. And now we need to go down here and open this little thing down here. This is the keypad. And in the keypad it has this function called functions. In our functions, we can go up here and we're going to go to this miscellaneous functions, where I notice that I have two different log buttons in here, right? So I have log and I have log of A. Well, the A is going to allow us to change the base in here, so this is the one we would like to choose. So go ahead and choose this one. And notice that the cursor pops down here at the bottom. Well, our function reads f of x log base 4 to the x power. So we're going to go ahead and make this the 4, and then we're going to put the x here. Oh, just kidding. We're going to go over one more and put the x there. And we can see that it went ahead and graphed that function for us. If this is where you were struggling, go ahead and just pause it and then go ahead and look at those other questions. If not, and you're just checking yourself, then continue playing. So I'm going to actually also put the other function in. Now I could put the negative notation in there, but it's really going to mess up my Desmos. So I'm going to just go ahead and say, hey, I'm putting a whole new one in. And since I still have this open right here, I really want to use this, right? Because I need to put this to the power. And I could do that just by this right here. So I could do, let's go over, back over. We're going to go 4 to the x power. And look what happened. Alright, so if you were still struggling on just graphing, please pause the video and answer the next few questions. If not, I'm going to help walk you through the next questions, which is, what do you notice about the graph? Well, you could have said a lot of different things. You could have said that they're like almost like flipped over each other, like reflected in a different way. Well, the key is that these graphs really are reflecting. An exponential function kind of undoes what the log does, right? So we saw that in that first assignment we had done, where we were asking you, oh, what base does this? What base? Well, we were really undoing that, right? We were undoing those exponential functions. And that is exactly what a log does to an exponential function. And an exponential function also does that back to the log. Let's think about what we know about inverses in math previously. So what we know previously is that if we multiply something by a number, to undo that multiplication, we have to divide it by that same number. That is called the inverse, right? If you add 2 to something and then you subtract 2 for something, you just inversed it or flipped it. Well, these are an inverse of each other, and they are actually reflected over the line of y equals x. If we mirrored these across this line, we would have the same exact function. And that's the complete point of inverses, is to undo something. So that should answer your next question. I'm going to flip over to a different screen. And then we can go back to this little paper right here where we can talk about what can you determine about the two graphs. I think something we can determine is it's almost like a reflection. So you could write in here, it's a reflection over the line x equals y, or something like that to that point. I'm not going to write anything here, I'll let you do that. Move down here to solve for the inverse algebraically. Alright, so what we're really doing when we're solving for the inverses, we're taking that original function, and I'm going to use a y instead of an x here. So y equals the log of 4 base to the x. And what is actually going on here is when we want to inverse the function, we're actually inversing the x and y. So we're going to flip flip it. We're going to say x equals log base 4 to the y. And then we're going to solve for y. And in order to do this, we're going to use that exponential to log rule that we have kind of learned, which is the base to the exponent equals the answer, right? We know that. Some number raised to some exponent will give us an answer. And the inverse of that is the log of a base is the answer equals the exponent. And this goes back to what I was telling you about logs to begin with, which is logs are just a weird way to ask a complicated question, right? So what base raised to some exponent will give me that answer? And I'll give you some more concrete examples of this in the future. But for now, let's just talk about solving for y. So now we can use this log to exponent rule to get us to y, right? So here we'll keep the base, which is 4, and we're going to flip those two, right? The x and the y. So we now have x here, and we're going to set that equal to y, and that gave us the inverse function. And then you're all set. So now your goal is to see if you can use this set of rules I just gave you about finding inverses, graphing those inverses, and solving them algebraically to a previous function that we had already known, which is a quadratic. So go ahead and try that now.